In this final clip, we're going to do two things. On the one hand, we'll look at multiple bonding. And on the other hand, we'll look at the more simplified way chemists tend to actually draw valence bond orbitals. So, molecules we'll look at are molecules like ethylene with a double bond, or acetylene with a triple bond, and we're going to look at the way chemists normally use valence bond theory for them. And the point is, which electrons are we more interested in? The electrons that are in the filled bonding orbitals, or the electrons that are in the unfilled antibonding orbitals? And the answer is, we're interested in the filled bonding orbitals. And it is convention in valence bond theory. By the way, valence bond theory goes by the initials VB. It's conventional to consider the bonding orbitals. And the filled, all bonding orbitals are pretty much filled in the molecules you get in this course, and the filled non-bonding orbitals. So this is the convention in valence bond theory. So let's see what we've got here. This carbon is what steric number? This one right here is steric number 3. This carbon here is steric number 2. We're going to use sp2 plus p hybridization here, and sp plus p hybridization. And if we just want to look at the bonding orbitals, the best thing to do is just imagine in your mind what sp2 plus p looks like. And I'm just going to draw the framework. This is the framework. There. I'm imagining in my mind. Well, I'm drawing them out. But here they are. And there's my sp2 plus p hybridization. And right off the bat, I can see two of them easily make a bond. And they are this one, they make a bond to the H. This one makes a bond to the H. And how can I make bonds with the remaining ones? Well, the one here, I'll call this one A, B, C, and D. A is pointing directly at the other carbon. So it can make a bond. Here I'll use another color. With this guy, they make a bond. And what kind of bond could D make with the new carbon, the purple carbon? Put in chat. This bond is a sigma bond. What kind of bond could D make? And the answer is D could make a pi bond. And we've now shown 2 of the 4 right-hand atom orbitals. We have 2 more to show. Should be just like before. We have this guy, so we now have this guy can make a bond here. This guy can make a bond here for E and F. This is C2H4. How many valence electrons is C2H4? Carbon has 4, 8, 12. 12 valence electrons, 6 filled orbitals. And here, shown here, are the 6 filled bonding orbitals. And it's very common to redraw this D in a different format. Here, I'll put it right here. Here, I'll put the 2 carbons, the hydrogen, so we can see what we're talking about. And if I rotate it, and chemists like to show that it's a pi bond. We show it like this, and we want it to indicate there are a pair of electrons. We just put pairs of electrons. So all these orbitals are filled, and these are the 12 electrons in the valence bond theory. And this picture, these are two equivalent pictures, one where it's easier to see. In exactly the same way, we can turn to acetylene, which is sp2, sp plus p plus p. Let's look at that. Here's the framework. I have this guy. This sp hybrid. I have the two remaining p orbitals shown here and here. And it's clear for this A, B, C, and D. It's clear that A can make a bond to this hydrogen over here, but what about B, C, and D? And again, we're going to draw what kind of bond can B make, sigma or pi to the other carbon? And the answer is sigma. What kind of bond can C make? And the answer is pi. What kind of bond can D make? The answer is pi. We've now drawn 3 of the 4 right-hand orbitals on the 3 of the 4 orbitals on the right-hand carbon. I must draw the remaining one, which I'm putting here. This one's E, and it can make a bond with the S. So C2H2 has how many valence electrons? And the answer is 10 5-filled orbitals. This orbital is filled. This orbital is filled. We draw the lines connecting the two. This one's filled. Lines connecting to this one's filled. And this one is filled here. And we just don't even bother to consider, oh, I've been drawing too many electrons, the antibonding orbitals, which also exist. And that shows you then the power of valence bond theory, that it doesn't require detailed calculations. Once you know the hybridization schemes, you can just directly write down the filled orbitals.